in the previous video, I said that our aim was to find out these equations here. But I shouldn't use the word equations because I should use identities rather than equation. An equation, suppose if you look at this here, an equation is true for certain values of x here. So this here is true when x equals 2 pi, 4 pi, and so on. It's only true for certain values of x here, whereas an identity is true for all values of x here. So if you look at this here, this will always be true regardless of what values you choose x to be. It will always be true. You see, all these here, these are identities because regardless of what values you choose alpha and beta to be, these will always be true. Whereas this one here, an equation, is only true for certain values of x. It's only true for this 2 pi, 6 pi, and so on. Okay. Well, anyway, back to our aim here. We set up a circle in the previous video. We set up this circle of radius 1, and then we realized that the length between P and R here, is the same as Q and S here. So this length here, Q and S here, the length there is the same as P and R here. So and then in the previous video we set up this triangle here, this right angle triangle here, and this length here was given by this. Okay, and by using Pythagoras we can actually work out the length PR. Okay, and this length here, the height here, is given by remember this length here is given by this, and then we use Pythagoras, so we've got to square it, and the height here is given by this here, but then we're using Pythagoras, so we've got to square it here. Okay, well anyway, so we can say at the end of the previous video it was PR squared, the length PR squared equals this thing here. Okay, so now it's just a matter of multiplying out the brackets. So here, this bit here, you can visualize as this a plus b squared, meaning a plus b. So this times this here would give you this. So basically, this times itself will give you 1. Okay, and then this times this here, and then this times this here will give you 2 cosine alpha plus beta. And then when you come to do this bit here, this bit times by itself will be positive. Okay, will be, because of this here, will be positive. Well, basically, this whole thing here is this thing here. Okay, when you multiply it out. Okay, this here remains the same. Okay, so from here to here, it's just us multiplying out this bit here. Okay, and then notice that if you look at if you combine these two here, remember I in one of the early videos I asked you to ingrain this inside your mind here. So when you have a unit circle, sine squared theta plus cos squared theta equals 1. I asked you to ingrain this inside your mind. You have to know this by heart. So when you have a unit circle, blah blah, this has to be inside your mind. Okay, basically, if you combine these two here, so hang on. So we started out with PR squared equals this thing here. We multiply out this thing here to give us this here. Okay, but now here's a trick. If you combine these two, because cos squared exactly the same thing, sine squared exactly the same thing, because these two are exactly the same. This here is actually 1. It equals 1 because of this here. Because of this, look, exactly the same angle here. So this thing here, exactly the same angle here, exactly the same angle here. So this thing here is really 1. Okay, so this here is 1. This here is this one here. So you can combine these two together to give you 2, and then you've got your minus. This is your minus here, 2 cos alpha plus beta. So it gives you this. So PR squared is given by this. Okay, and then our next aim. So we've got PR squared. Okay, so we've got this length squared. So that's this whole area here. Now our aim is to find out our next aim is to find out QS, and then later on we're going to square it. So this area here later on will be the same as this area here by using Pythagoras. Okay, well, because this length here is the same as this length here, then later on PR squared will be the same as QS squared as well. Okay, well, anyway, our aim now is to find out this length here. Okay, so hang on. So our aim here is to find out QS. Okay, but the thing is, I'm going to zoom into this bit here. I'm just going to zoom in to this bit here. So this bit here, I'm going to move it down here. So I'm going to zoom into here. Okay, so now zooming in. So this is me zooming in. So Q is here. Okay, P is here. S is here. Okay, so if you go back and have a look here, hang on. Q is here, P is here, S is here. So if you move it down here, hang on, Q is here, P is here, and S is here. Okay, our aim is to find out this length here. Hang on, our aim is to find out this length here. Okay, but then we're going to draw a vertical line down, straight down, and then straight across here, we've got ourselves a right angle triangle here. So here, our aim is to find out the length QS here, the length QS. But the way we do that is to draw a vertical line down here. So really, this triangle here is a really thin triangle, whether it's a thin triangle like this. But it is a right angle triangle. So this here is your Q here. This here is your S here. Okay? And our aim is to find out the length QS. Now, the length QS, well, we're going to use Pythagoras. So QS squared, which is, hang on, QS squared here, which is this, well, remember this triangle here, we're going to use this one, it's easier to see. Okay, so the length QS, we're going to get, hang on, we're going to get this length squared. Okay, so this length here will be given by this, will be given by cos alpha take away cos minus beta. Okay, and the reason for that is, hang on, if you, well, okay, we're going to draw this triangle here. Okay, hang on, bear with me, and then a line straight down, and then straight across. So here we've got a triangle. Now we want to know this length here. This length here. You see this length here. If you look at this here, looking at alpha here, if you draw a line straight down, hang on. If you look at it, if you draw this line straight down here, okay, so looking at this point here, and then from the S, draw a line straight up here, you see this gap in between the two here represents our triangle earlier. So this was our triangle here. This length here is given by this gap here. Okay, so well the length from here, this length here straight to the origin here is given by, looking at this alpha triangle here, is given by cos alpha. Okay, so cos alpha will give us, hang on, cos alpha here will give us this length here. From the origin here to here is given by cos alpha. Okay, now from the S, draw a line vertically upwards here, and then this length here, from the origin to this length here, is given by cos minus this beta here, cos minus beta. So when you cos minus beta, it will give you from here to the origin here. So if you want that, looking at our triangle earlier, if you want this length here, you would have to get cos alpha take away cos minus beta. Okay, so it's basically this point here take away this point here. That will then give us the gap in between. Okay, so that's why we've got. So remember, cos alpha take away cos minus beta. So look at this here. Cos alpha take away cos minus beta, and then so this here is our length here. Hang on. So remember, our triangle is like this. So this length here is given by this, but then we've got to square it because we're using Pythagoras. Okay. So yeah. So this bit here, Pythagoras, this bit here is given by this. Okay, and then this here is given by this. Now, if you want to know this length here, the height, if you want to know the height, look at this. Back to this triangle here. Remember, we're joining a straight line from Q to S, and then draw a vertical line down, and then straight across. This is our right angle triangle. So you can visualize that triangle as this triangle here. Okay, and well, this height here. Well, looking at height, how would you find the height? Well, if you look at this triangle alpha here, the height would be looking at the triangle here. Okay, looking at this alpha triangle here. Sine alpha will give you the height from here up to Q here. Okay, from this point. So if you sine alpha, that will give you the height from here to here. Okay. Now you want to add it to this length here. Well, this, remember, from here to here. Our aim is to find out the vertical height, but then this from here to here, it is sine alpha here. But then we've got to get it from here to here now. Well, from this height here is well, looking at the minus beta. This length here is sine minus beta. Okay, so that then will give you this length here. Okay, so this, hang on, let me clear this up. So our aims, well, a line joining from Q to S would be this, and then draw a vertical line down here, and then form ourselves a right angle triangle. Now this height here is given by sine alpha. Okay, now we need this length here. Well, this length here is given by sine minus beta, because you got to consider this triangle now. Okay, but you're only interested in the height. So basically it's going to be this and then this. Okay, but the thing is, let's say the thing is the height here would be this, take away this, because hang on. So if you look at this here, sine alpha is this bit here, and then this bit here. Remember, sine minus beta will give you this here. Sine minus alpha beta here will give you this here. But then there's a minus in between here. Now the reason for the minus is that when you sine alpha, let's just imagine it to be positive 3, because yeah. So here the height is positive 3. When you sine minus beta, it's going to give you a negative. Let's say negative 7. Okay, because our coordinates would be, this here would be positive, down here would be negative, up here would be positive, down here would be negative, over the left hand side it would be negative. Well, when you sine minus beta, it will be a negative down here. Let's just imagine it to be negative 7. So to find out the whole height here, it would be you getting 3 minus, so it would be you getting 3 minus, and then minus 7. You see, in order to get the whole length here, because you know that when you sine minus beta, it will give you a negative. So you've got to have this minus here. So imagine it to be like this. This length here is 3, alright, and then when you sine minus beta, it would, let's just imagine it to be minus 7. But for you to get the whole length here, you would have to get 3 minus 3 minus minus 7. So the point is that this thing here is sine alpha. Down here is going to be sine minus beta, but then the whole length will be sine alpha take away sine minus beta here. So the whole length here will be this, and you do need this minus in between. Okay, so that will then take us to this. So I will continue in the next video from here. Okay, yeah, so QS squared equals this whole thing here. Okay, I will continue in the next video.